Here's another example involving the distance formula. This one involves airplanes. Turns out that the wind, when an airplane is up in the air, has the same impact that a river current would have on a boat. In that, if the plane is flying into a headwind, so the wind is pushing against the plane, it's going to slow the plane down. Whereas if the plane has a tailwind, so a wind that's coming from behind, it's going to speed a plane up. And it turns out it's going to do it exactly the same way a river current does. The speed of the wind is going to add on to the speed of the plane or subtract away from the speed of the plane. So in this example, in still air, a particular airplane maintains a speed of 250 miles per hour. If the wind is blowing, the airplane can fly 670 miles with the wind in the same time that it can fly 450 miles against the wind. What we want to do here is find the speed of the wind. So let's look at that information again. 675 miles with the wind in the same time it takes to fly 450 miles against the wind. Same time means the times are equal. So the time with the wind, so the wind is helping the plane, is going to be equal to the time against the wind. The wind is hindering the plane. Okay? Remember, time can be written as distance divided by rate. So time is distance over rate. So instead of writing the time directly, we can think about it as distance over rate and distance over rate. The thing we're trying to find is the speed of the wind. So that should be my variable. Let's let x be the speed of the wind. Now, the speed of the wind is not going to be our denominator. Our denominator has to do with how fast the plane is flying. Our numerator is how many miles the plane flies. So if you're going with the wind, which was this first statement, my distance is going to be 675. Now the rate, though, if I'm going with the wind, so the speed with the wind, is going to be better than the normal speed. The speed is going to be increased. So my normal speed is 250 miles per hour, and we're going to increase it by the speed of the wind. So we're going to add x on because the wind helps the plane. So my first denominator is 250 plus x. Now, again, I'm adding the current onto the speed of the plane because the speed of the plane has to be faster. So you always want to start with the faster object. The plane is faster than the wind. If the plane wasn't faster than the wind, then you'd be a problem, right? Not so much when it's going with the wind, but if it's coming back, there's no way it's going to be able to fly into the wind if it's not faster. So always think about the airplane or the boat being the first thing you write down in the speed. The other side of this equation has to do with going against the wind. When we look at the speed against the wind, we want to think about, again, the airplane as being first. Its speed is 250, but now it's being hindered, so you're subtracting the wind speed from the airplane speed. So I can go 450 miles at a speed of 250 minus x. And that would give me, when I divide them, the time that it takes against the wind. So here we have our setup. 675 divided by 250 plus x, because we are going with the wind, so we're adding the speed of the wind to the speed of the airplane, equals 450 over 250 minus x, the speed of the plane minus the speed of the wind, because we are losing speed because of the wind when we're going against the wind. Now this is a proportion. So to clear the fractions, just set cross products equal. So 675 times 250 minus x equals 450 times 250 plus x. Feel free to use a calculator. Multiplying this out, 675 times 250 is 168,750 minus 675 times x equals 450 times 250 is 112,500 500 plus 450x. Now we've got variables on both sides, we've got numbers on both sides. Let's move the variables to one side. This is a negative 675, so I'm going to move it over to make it positive. So 168,750 equals 112,500 plus 450 plus 675x is going to give me 1,125x. Move the constants to the other side, so subtract 112,500 from 168,750, and that would give you 56,250. Again, feel free to use your calculator. That's what I did here. These numbers are rather large. And then to get x by itself, we divide both sides by 1,125. So when we do that to both sides, we get x equals 50. Comes out nicer than you maybe suspected. So x is 50, but what was x? X was the speed of the wind. That's why we write down this definition. Is by the time you get through this algebra, sometimes you forget where you were to begin with. That's why it's important that you document as you go what you're doing. So x is the speed of the wind. So this is the speed of the wind at 50 miles per hour. If we're right, it should check. Let's go ahead and write it out, just assuming we're right. The speed of the wind is 50 miles per hour. Let's check it to just make sure we were correct. So remember what it said is that if we're going with the wind, so if we're going with the wind, we can go 675 miles. So 675 miles divided by the speed with the wind. Well, if we're going with the wind, that means I'm going 300 miles per hour because 250 plus 50 is 300. That would be with the wind. So if you use your calculator, you can take 675 and divide out the 300. And what you get is that the time it takes you to do that is 2¼ hours. So again, this was miles per hour. So we get hours out of that. That time should be the same as the time that going against the wind, 450 miles. So 450 miles divided by, against the wind means you're only going 200 miles per hour. And if we then calculate that, 250 divided by 200 equals 2¼ hours again. So the logic of this answer makes sense.